Let's talk about power. Power is TPD, total power distribution. When you put more power, you can drive your memory faster. Obviously, all these pins here need to talk to all those signals on your memory bus and drive it a little bit faster. What else do you get with power? You can have more cores. Obviously, you got so many CPUs running, you got more power. Or you also have frequency or clock speed. The higher voltage you run, the more faster you can bing bang your transistors inside, and goes there, you get more power. What you're going to see is that lower cores support higher clock speeds up in the 4.5 and that. What is the EPIC line designed for? It's designed to run reliably in data centers and run consistent under heavy loads. We start out here with, again, our 7501, which is a 32-core PCIe 3.0. You can see here it's 0.47 pounds. This here was built out. It's got a big copper heat spreader. This thing here only went in, I believe, at 180 watts. So it didn't support all the cores. What was that tied to? That's tied to the voltage regulators on your motherboard, how much heat it does, and how much memory it can do. Quickly, they came out with 7002 ROM. That supports up to 240 watts. You can see still it's the same package. They knew it was coming. 0.47. It's got the same amount of copper in it. This is anything ending in a 2. 7002, supports up to 240 watts, goes up to 64 cores. You're only going to see these come in, even in the smaller cores, around 3 gigahertz. Designed to be reliable, lower total power. Okay, what do they need? They need to come out with new cores, new instructions, and everything else. They're coming out with 7003. 7003, what do we get? 0.49. A little bit more copper in there. Supports more power, a little bit better, 280 watts. What are you doing there? How much it is. How much copper spreads out that heat, allows you to run those a little bit faster. It comes up with a new refresh. Obviously, a new die shrink from TSMC. What does it go in then? You want to go in 500 watt SP5s. What are you at? 5.2. This is huge. This is a big, heavy CPU. What is that? 4.6. You're 9.6. Almost half of, it's still a little bit over half of each of these CPUs what you have here. What is this allowing you to do in total power? This socket can go up to 500 watts if it's liquid cooled. You're going to have a problem at 500 watts because not only the heat comes up the top, the heat goes down the bottom and into the pins of the motherboard. What is that required to dissipate that amount of power and everything else? You need a motherboard that's really, really, really heavy. This here is a workstation board right here based on Threadripper. This thing has all this copper on the bottom. What's that doing? That's taking the heat out here, distributing it back up into these heat sinks there. This whole thing here, 6-pound board. PCB board in here should have been about half a pound. This has got 5.5 pounds of metal just in cooling around here. So this is, again, an Asus X80E. This is the Sage boards. This is used for the Threadrippers. Same socket, you can see here, SP3. Going to have different notching. Going to perform differently, only designed for Threadrippers for workstations. So we talked a little bit about power, how weight influences it, and how the copper spreaders goes. You got power coming up the top, you got power going down the bottom. Why do they need a new socket? Well, they're going up to 1400 watts liquid cooled. They got to make sure nothing melts. Where are your voltage regulators that drive that amount of power? They're right here, underneath all of your heat sinks on this board. The size of that is dependent on the components. The 32 cores in the 7501s have smaller original releases, have very small voltage regulators. If you need to support something between a board, between the 7002 and 7003, you got to make sure you have enough voltage regulators to do that for the higher wattage. That's what cleans your power, drives the CPU. CPU asks for more power, less power. That's your voltage regulator does that. So VRMs, we talked about power and a little bit about the difference in the boards and how it influences the sockets. And you even saw a little bit of difference in weight, how the faster, newer CPUs need more copper in them and they're heavier to support that. So